Hi, I'm Curtis Brown, and I'm here with my friend Robert Ahdoot, and we are here doing some smart space videos for you. I'm super excited to introduce this video. We're going to be doing some more transformations of equations and relationships. And in this section, we're going to be using my phone data and how it relates to Robert's phone data and screen time. So let's go ahead and we'll get started. All right, so I'm going to share my screen.
If I ground you, no more cell phone, just letting you know.
Do what?
I'm going to ground you, not allowed to use your phone anymore.
Oh, you can't do that. You can't do that. I don't know if I would be able to function
I need it for work. I need it for work, Dad.
I'm telling you, I need it for work. All right, so here's the deal, Robert. We started off with your data a couple of videos ago, looking at the fact that you use your phone at 3 hours on average per day, 3 total hours of immersement in that cellular screen, that blue light shining right into your eyes for 3 hours a day. Kind of collected that data. We've got that data plotted here. We notice that we've got a slope of 3 hours per day. We see that happening here. We've got this really nice relationship that we see. Okay, so I have 1 day is 3 hours, 2 is 6, and so on, right? That's my data. I've got this equation here. We talked about it as 3 times the number of days. Now, that's sort of our initial assumption, right? Our initial relationship. But remember, I said we were going to use mine in this particular video. We're going to talk about my data. Now, it turns out I did a little bit of research. I looked on my phone, went back, looked over time, and it turns out that, Robert, my phone screen time is 1.5 times your screen time. Use my phone 1.5 times more than you do.
Wow.
I am immersed in my phone 1.5 times more. Remember, no judgment here. No judgment.
No judgment. No judgment. Right there.
We're not judging here. All right. So I'm going to actually make a relationship. I'm going to actually make an equation, okay, that says my phone time. I've got a column here called it Kurt phone.
Cool.
You know, a lot of times I go by Kurt. Doesn't really matter. Kurt, Curtis, whatever. Just a number of letters, two less than before. All right. So I'm going to make that relationship be 1.5 times, I'm going to multiply Robert's phone time. And this was phone.
Call that phone hours.
Phone hours, and I'm calling this Kurt phone. And it's going to be 1.5 times phone hours, which I think we had as Robert's phone hours. So now you can see if we went down this relationship 3 times 1, 4.5, right? So we got that relationship. All right.
Wow.
So now I'm going to plot my data alongside of yours. We're going to actually look at these two at the same time. Okay. So I'm going to just put that one up there.
Whoa, cool.
So now check this out. Isn't this crazy? This is crazy. So my phone time is these yellow or orangish colored squares. All right. All right. And yours is that series that we had there of blue circles, right? Okay. So this equation, y equals 3 times x, that is your relationship. Now our task here is going to be trying to figure out, what is this relationship? What do we need to do to come up with this relationship? Now, I can do a couple of things, right? I can actually just multiply times your relationship here, right? We can actually take that 3x and multiply by 1.5. So we could look at that and see that stretched out. Now, what do you notice about each of these? Are they the same distance?
No, they're not. That's really cool.
Vertical distance before. We talked about adding 6. Remember, we talked about that adding 6 hours, right? You went to moms and you had used the phone for 6 hours. So that just like translated it up 6 units.
Right.
It doesn't look like I'm translated up the same amount.
Right.
Looks like the difference is different than that. So what else could we do? Well, let's see if what I did over here to create that set of numbers actually kind of makes some sense. So let's actually go in here and let's plot a new function. Let's plot a new equation, a new relationship. So I'm going to just go in here. I'm going to plot a new relationship. And this time I'm going to plot I'm going to take that relationship that you had there, 3x. I'm going to multiply it by 1.5. So I'm going to say 1.5.
So in front of my function.
In front of your function.
Right.
Now I could do this as 1.5 times that f6, but I think that notation gets a little bit.
Right.
So I'm going to just take that 3x that we remembered what we had before. That was your relationship, right? 3 times x. That was your relationship. So I'm saying 1.5 times that original relationship that we had in there. So watch what happens. This is going to be really cool. I'm going to see that graph, right? It's there, and totally it. So, man, it looks like, I'm going to look along here. I've actually stretched out. We call this a dilation. In geometry, we talked about the idea, maybe in 7th or 8th grade, they may have talked about the idea of a dilation of a shape. Well, now we're dilating just the y-axis here. We're just multiplying that. We're just scaling that y-axis by a factor of 1.5. We're actually taking that and we're multiplying every value by a factor of 1.5. And we see that.
Every y value, right,
is 9.
Every y value multiplied by 1.5. That's what's interesting. Right. You know, if you compare each of those points, top and bottom, up and down, like students should ask themselves, what's changing, x or y? See, here's 4, 4, 4, 4, right? The only thing that changes, 5, 5. So when we multiply 1.5 at the beginning, we're changing the y value. And I'm glad you compared it to vertical shift. We're not moving the line up and down by 6 this time. We're doing exactly a vertical stretch. And I like to think of it as vertical stretch because that gives me a chance to go like this. Now, check it out, right? So tell me to vertically stretch.
Vertically stretch. Oh,
see what I did?
Higher than you were before?
Right. See the arm, it went, here, actually it'd be more like this, right? Am I aligned with it? So vertical stretch.
Yeah.
Vertical stretch. It's like if you believe in the higher power, it's coming in and pulling it up. It's like vertically, like I can see fingers coming in and pulling it up.
I mean, I don't want to get totally crazy here, but like, it's like I grabbed this point, right? Like I grabbed this point and I just went and drug it right up there. And we see it just go,
stretched it.
And stretched it right up there to that point.
Yeah. So it's a stretch vertically. So it's exactly like the way it would be. And then I love the idea in the previous videos, we've been talking about how that relates to all graphs. So if I was a parabola like this.
Oh, sure.
And let's put 1.5 in front of a parabola and it'll look like my actual arms stretching. So, it's pretty cool.
Wait a minute. So if we did, you said that parabola. So let's take that parabola. Let's say we had x squared.
Right. So here's me on a normal day. This is me pre-yoga. I am not stretching yet.
And then if I just take that graph and I just go.
Yeah. I'm stretching vertically. Stretch vertically.
We just stretched it vertically.
Right. So that 5.22.
Vertically.
And then go make it less than 1 now.
So now let's take that same parabola. Ooh, and now we're less than 1.
And now vertical compression. I feel like the ceiling is lowering in on me. And wouldn't you be like, if the ceiling was lowering in, vertically compressing us, wouldn't it be like this? Like, oh no, like this. I feel like,
like, that's exactly it.
Oh my God, no.
I think I've seen a movie where that happened before.
Right, it's really horrific.
I'm fairly certain I've seen a movie where that happened before. No, but that's exactly it. So we're taking, just to relate that back to the language, right back to what we talked about in 7th or 8th grade, right? We talked about that idea of dilating figures and making them bigger and smaller, and we had all these scale changes that happen. That's exactly what's happening here. We have this vertical dilation, all right, a vertical scale change, all right, that either results in looking like a stretch. So when we're greater than 1, it absolutely looks like or appears to be this vertical stretch. Of course, I could change the window and what it would look like might change, might look.
No, you're right. No, yeah,
right?
stretch.
And the
up.
same thing in the horizontal, or if we shrink it back,
Compress.
it's this compression.
Compress.
If we change the graphing window, it would look a little bit different. But the idea is that we're either getting bigger faster and faster than we were before, or we're getting bigger slower and slower than we were before, right? And that's evident based upon this picture that we saw here. Look at what's happening. This graph is increasing at one rate. We remember it was 3 hours per day. Now we're increasing at whatever 3 times 1.5 is, 4.5 hours per day. So
yeah, 4.5 hours per day.
4.5 hours per day, and we can check that. 4.5, up 4.5, right, 1 to 9. 4.5 plus 4.5 is 9, right? Plus 4.5 again.
Yeah.
13.5, right? Plus 4.5 again, 18. 4.5 again, 22.5, right? So we're going up by that 4.5. So we're actually 4.5. We're actually stretched this thing out by 1.5 times Robert's original 3x.
Yeah.
Wow, totally cool. The idea, this idea of vertical dilation, vertical stretch.
Yeah, like it changes the curvature. That's right. So now that we've uncovered this idea of vertical stretch versus vertical compress, we can even go a step further and ask poignant questions about how much or how little of a life that we have, because we're on our phones all the time. So
yes.
would you like to dive in and become depressed with me?
I think let's do that. I think let's actually do that. I'll let you share
let's
your
get
screen.
depressed. I'm going to share my screen now. Let's get depressed.
You're sharing your screen.
Next.
So this is a crazy thing, right? So we're actually going to use the tools that we've been talking about. This uppy downy sort of stretch. We're going to talk about these in terms of days of our life that we spend on our phones.
Right. So let's talk about it. So right now, you see this, y equals 3x? Yeah. Okay, cool. So this is what we've been talking about before. 3 was our slope, 3 hours per each additional day. Y we knew was measuring the phone hours. So we have phone hours here. And then we have x is represented by the number of days of life. Right. So for each day of life, when x is 1, we have 3 hours. When x is 2, we have 6 hours, and so on, right? But you posed the question, and I want to pick up where you posed it. So if this is true, if we spend 3 hours a day, every day average on the phone, so what if I wanted to say, I don't want to talk about my hours on the phone. I want to sadden myself and talk about how many phone days, like sheer entire days on the phone, 24-hour blocks on the phone.
Okay.
And X is now not measuring the days that traverse through our lives, but the number of months in our lives. So what we're now asking, remember early on in one of the first videos, we said, can we ask pointed questions? Can we almost be provocative in a way and really distill all the data to make interesting conclusions? So yeah, one that definitely interests us in a morbid way is how many days do I spend on my phone per month? So let's give it a little shot. So if X is over here, I'm like literally shaking, Kurt. I'm just letting you know. 1, 2, 3. I don't like.
My data is more extreme than yours.
Yeah. Yeah. That's like in Don't Mess with Texas. Don't mess with my data. Don't mess with my data.
My data's
popping. So we have months, right? So my question is, if X is the number of months, how many sheer days are spent on my phone ski? All right, here we go. Let's do it. So let's
find out.
3 hours every day.
Hey, I know
let's
how many
assume
days there are, hours there are in a day. 24.
24. Yeah, we'll get to that. But I want to know, like, if we're doing 3 hours a day, let's assume a month is 30 days, you know.
Oh, sure. Okay,
yeah.
great.
So we're going to go 3 hours. So we're going to get the sheer hours per month. That would be helpful.
Okay.
So if it's 3 hours a day, three, propagated out over 30 days. So this is why we're doing this. What's interesting, this is kind of what's fun about why we're doing this, is 90
That's
total,
90 days, 90 hours.
90 hours. But that, look, 90 hours is not super understandable to everyone. Right?
It's not to me. That just seemed like just sounds like a lot of hours. But
that's just like a lot of movies, or a lot of
that's like 15 movies, right?
Right. Yeah. Depending on who your favorite director
well,
is.
Okay. So if it's, some of these really long movies, sagas, maybe.
Right. Yeah. This phone stuff is a saga. So check it out. So if we're doing 90 hours, this is 90 hours per month. So then we would say, okay, so if there's 90 hours spent on the phone per month and there's 24 hours in each day. So we ask ourselves, how many 24-hour blocks can we fit inside here, right? How many 24s fit inside 90? And we have here, to do it straight through calc. Why not? Let's do it. So we got 90 divided by 24. That would mean there are 3.75 24s hiding inside 90. Essentially, that means 3.75 days on phone per month.
Oh my goodness. 3 3/4 days per month.
Yeah, almost 4 days. I like when you use things like that. Almost 4 days. So
Almost
just over
4 days.
Yeah, so we got 3.75 days. We're talking sheer days, right? So if we have,
we're talking like one revolution around the earth, like,
yeah,
miles is 24,000 times 4. So you're talking about roughly 100,000 miles worth of hanging out on your phone. Sorry, I totally just did not.
I know. I'm telling you, I told you we're
like, no,
that's
real. It's crazy, right? We're spending that much time on the phone. This is way cool, but we're using the scale. So can we now make the relationship?
Yes. So if we're saying right, so now if it's 3.75 days on phone, we're having phone days compared to the number of months. Essentially, what we've discovered is that average goes right here. That average is the slope. That average is the slope. For students in advanced classes, I encourage you to think about, like, slope and average go hand in hand. They truly do. They truly do, because it's a rate. It's an average rate, up and over, up and over, up and over. So shall we? Can we throw this back on yours and start to and continue to depress ourselves? All right, I'm stopping the shit. All right, taking it off. Go ahead.
Uh-oh, you just saw my kid. All right.
That's great. We're doing it for him, man.
Yes, totally doing it for him.
That's a good example.
So check this out. I've got us a new place to play here. So I've got months ready to go. I've got phone days as another option here. And you just told me that phone days, all right, phone days are equal to 3.75 phone days per month, right?
Correct.
3.75 phone days per month. So I'm going to just put that in there, 3.75 phone days per month.
Cool.
We're just going to drop that in and see that. Okay, so 3.75. In fact, I want to do this a little bit differently because you use the data. Hold on. I want to reverse that. I want to do this a little differently even yet.
Okay.
If we did that and related it to the number of hours that you had per day, like you were doing earlier, right?
Yeah.
We had that relationship. So you said it was 30 times the number was 3, right?
Times 3, right?
Times the number of days, right?
Right.
And then we took that entire value and divided by 24, right? 24 hours.
That's right.
Okay. Yeah, I do want to overwrite that data. Cool thing is
there it is.
numbers. But I just want to be really sure that what we did was that same scale change. What we did was we actually took that original picture, which was days to phone hours, and now we're graphing this as months to phone days, right? So we've scale changed that just a little bit. Earlier we did days to Robert's phone hours, and then it was days to Kurt's phone hours. And now we're saying months to Robert phone days, okay? Months to Robert phone days. So that's how we're gonna scale change this just a little bit. So let's look at that picture. Let's look at that picture. So here's our months. Drop in the months there, 1, 2, 3, 4, 5, 6, okay? And then we're gonna drop in not Kurt phone. We're gonna drop in phone days. See this relationship plot out. Now, you told me a moment ago that the relationship or the equation was 3.75 times x.
Yeah.
So there we go. Now we've got our relationship. Totally crazy cool relationship. So wow. Almost 4 days per month. 4 days per month. How many days would that be in a year?
Good. So why don't you just go over? Yeah.
Let's go up here and just see what we get.
Maybe you could type in, oh, 12 months, right.
So let's just kind of see 12 months. So if I just do a little, if I just do this and I get close, I don't have to get exactly. If I just kind of get close, let's just see 12 months.
Oh Lord. Oh my God. Please.
When that gets up there to close to 12 months.
No.
We're talking about roughly 45. In fact, it's exactly 45 days. 45 days. 45 times around the circumference of the earth. 45 revolutions around the earth. 45 days glued to the phone. It's crazy.
Hopefully I was doing other productive things at the same time.
That's just amazing. This reminds me, in fact, I'm going to stop sharing because I think we're about to wrap this one up, but this reminds me of those, those things where they talk about how many hours you sleep during your life or whatever.
Yeah.
I don't even want to know how many days of my life, or maybe even, I don't know, months or years of my life that I've spent like glued to my phone.
Well, look, I want to just say, like, in sincerity, the reason we're doing this, it's fun. I do feel like it in my body, and I breathe through it. It's very personal, but the idea behind this, why we're doing this exploration, is to empower people watching. Really, that's what it is. So if that information shocks me, I can take steps to change it, or I can monitor it better, or I can be in more control of the steps I take throughout my life. You know, like
right.
Knowledge creates wisdom, and we're becoming wise to our own life's processes, and that to me is a beautiful thing to share. And I'm glad we're doing this. So thanks for helping me dive into my life here. You know? Totally
agree. I'm learning some things about myself as well, and I also think that, you know, using this context that we're using right here, you know, math, it really is how we explore our world, right? It's how we understand and make sense of the way that our world works. And so that's why we're using this particular one, because we get a sense of what our world is like, and how much time we really are spending on this. And I think it makes the math makes us understand it better. It gives us some realizations and some insight into all of this. So Robert, it's been a whole lot of fun doing these lessons with you. I think we've got another one to do. So we'll see you next time. All right.
All right. See ya. Bye.